waiting for like a big red flashing light at the back to say, you're live. Brilliant. Well, good afternoon, good morning, good evening, wherever you are in the world today, whether you're here with us in London or whether you're on the broadcast somewhere in the world. Thank you for attending this event, the launch of MicroCloud, the new addition to Canonical's portfolio. We will have about 45 minutes, 60 minutes of presentation, and then we'll do a Q&A. If you're in the room, we'll do a live Q&A. I'll be roaming around with a mic. If you're remotely, you can ask questions right now. We'll be collecting them throughout the session, and we'll be asking them towards the end. I'm Thibaut Ruffino. I'm the VP of Marketing at Canonical. And a few people in the room earlier on said they were not too sure who Canonical was. So let me play a quick video for you.
Open source is all around us. Whenever you drive, shop, stream, call your friends and family, or look into the depths of the universe, you use open source in some form. But while it plays a key role in our day-to-day lives, open source isn't always easy to use. In fact, for most of its history, open source has lived in the domain of experts. That's why we started Canonical, to make open source easy for everyone. Back in 2004, we created a user-friendly Linux OS called Ubuntu. Today, it's the most popular Linux distribution, with users that range from startups to governments to Fortune 500 companies. In fact, any service you use online today has likely touched a machine that's running Ubuntu. Today, Canonical extends the principles behind Ubuntu to a wider portfolio of open source products. Our reach spans from the smallest devices to the largest clouds, and from the kernel to data-intensive systems. Whether you're developing AI models for self-driving cars, building next-generation telco networks, or critical infrastructure for financial services, Canonical technology enables you to build products at speed and with confidence and operate software at scale. Working closely with the open source community, we deliver trusted open source for everyone.
All right, so I guess now things are a bit clearer. Canonical is here to amplify the impact of open source in the world. Whether you're talking about industrial robots or MakerBots, whether you're talking about fanless edge gateways, or whether you're talking about cloud infrastructure, that's the kind of thing we do. And we help people use open source. We're not alone in this journey. We work with a bunch of users, developers, translators, testers, who are here to make today Ubuntu the most used, the most tested Linux in the world. We're applying this knowledge across the board, as I mentioned, across devices, across verticals. And more importantly, we've been doing so for 20 years. And for 20 years, we've been helping people take this complex open source supply chain and consume it to build your innovation. So let me give you a quick whistle-stop tour about what happened in the last 20 years. 2004, as you heard in the video, is when Ubuntu, the Linux for human beings, was launched. Ubuntu Desktop was made available for free for anyone from Calcutta to California, and was used by developers, whether you're a computer science graduate all the way to an enterprise developer at the top of their game, to build today's services. This success, this preference that developers gave to Ubuntu, led to Ubuntu being the first OS available in the public cloud. And today, the choice by default in a number of public clouds, and the leading guest OS there. With the start of the software-defined revolution, whether it's software-defined compute, storage, network, this has all started with Ubuntu. And going from the public cloud went all the way to the edge. The single node edge compute running Ubuntu or your latest cloud native workloads available there at the edge, while offering a resilient, resilient system. Now, you might know this story already, but what you might not know is what we started doing towards the start of the year, which is giving the ecosystem of application, middleware, infrastructure, born on Ubuntu, we started offering Ubuntu Pro. Ubuntu Pro is a subscription to open source, allowing you to consume open source in a secure way, in an easy way, whether you're talking technically or commercially, so that you can concentrate on building your own innovation on top, not just thinking about what's happening underneath. Today, we're here to talk about one area that open source, I believe, could do a lot of changes in. And this area is the private cloud. Everyone's got a private cloud. Everyone thinks, oh, it's complicated. You have really talented people taking care of the tin, bit of a grunt work type problem. It's time to change this. And to do so, we're introducing MicroCloud, and I'll let Miona talk about this.
Thank you, Tibor. Hi, everyone. Thank you again for being here with us today. My name is Miona Aleksic. I'm a product manager, and together with me, I have my colleague Tom, who is a senior engineer from my team. We will be talking a little bit about why we have built MicroClouds, what MicroClouds are, and most importantly, we will actually be seeing them in action running on this little box in the middle of the room. Now, I don't want to spend too much time on the introductions, but I do want to spend just a few minutes talking about the way cloud computing has evolved, just in order to set the context in terms of what we have built and why we have built it in the way we did. I'm sure that audience here in the room is, of course, aware and familiar that public cloud revolutionized the accessibility of compute resources, and it just made our lives easier. Everything was at the tip of our fingertips. You didn't need to provision servers. You didn't need to order hardware. You didn't need to, deal with a bunch of these things. You would just kind of click through, get the services you need, and everything you have is up and running in minutes. However, we are now in a mature stage where we're realizing that one model doesn't necessarily fit everyone. Public clouds are still important and will continue to be an essential part of everyday businesses, but due to a variety of reasons, it may not be the choice for everyone. Whether it's due to control or regulation, simply in some industries you would want to have complete control of your infrastructure, or you may not need to, but you may want to. There is also quite a bit of complexity in terms of the way public clouds are used, and you would need specialized skills in order to operate them to their full extent. And of course, cost is becoming an increasing concern because when we're running things at scale and during a long period of time, costs can easily and quickly accumulate, leaving us in a little bit of a trouble. On the private cloud side, private cloud solutions have evolved quite a bit, but they have inherited complexity. And regardless of whether we're talking about open source or proprietary existing private cloud solutions, all of them have been built over decades. So as technology was evolving, we have been kind of adding things to support these new use cases. We have been adding capabilities, but we haven't really been removing any. And that's why nowadays most of the existing private cloud solutions are also quite complex and can be very difficult to get in. But at the same time, we are now witnessing a shift in the market. More and more things are not happening in the central data centers, they are happening elsewhere. And in 2022, more than 50% of all enterprise-generated data was created and processed outside of the traditional data center. And what this means is simply that compute needs to be closer to consumers and the data. So cloud infrastructure as a whole is moving towards a more distributed model. And I'm not necessarily talking about edge computing here. I'm just talking about the need to have smaller clusters of compute in a variety of locations. It may be just a few, or it may be thousands of far edge sites in some use cases. But there is a need for us to have an easy way to deploy our clouds all across that is replicable, simple, and doesn't require specialized skills. And this is what MicroCloud is really all about. With MicroClouds, we created a solution that takes the familiar existing infrastructure components, but makes them more effective in a distributed environment. It is a simple, opinionated unification of compute, storage, and networking, But at the same time, we are adding some functionalities that are relevant in this distributed space, such as remote operations, over-the-air upgrades, and self-healing capabilities. So essentially, MicroCloud is really a cloud, but localized. It has all of the good bits that a cloud needs to have. It has automation built in, and it's very easy to deploy. It has, everything is API-based, so you can easily manipulate it and adjust it and integrate it with different tools that you would like to use. It's quite cost-friendly, so the economics of it are good, but at the same time, it is localized, so you can kind of spread it across your estate in the way that suits your use case. Now, I do want to address the elephant in the room. Why are we calling this solution micro? Is it really, really that small? And does it need to be just really, really small? The answer is not really. The reason why we're calling it micro is not because it's small at scale, but because it has a small footprint. MicroClouds themselves start at 3 servers, and the reason for that is that they are highly available by default. So we don't support single node deployments because we want them to be able to heal themselves and to recover from any mistakes. But they can scale up to 50 servers, so basically a whole rack in a data center. In terms of the components, this is pretty much what a MicroCloud looks like. Of course, there is an operating system. In our case, it is Ubuntu. And then we have 3 main components that comprise our MicroCloud. First is Ceph, which is really de facto standard for open source software-defined storage. It is very useful because it provides interfaces for several different storage types, block, object, and file, within a single cluster, which means that you can use one single storage provider for all of your needs. In terms of virtualization and orchestration, we are using LXD. And LXD really has been a Canonical baby over the past 8 years or so. It is a modern infrastructure tool that has everything you need to run your virtualized workloads. You can run traditional virtual machines, but you can also run system containers that behave similarly, but are more resource efficient and provide near bare metal performance. LXD is really the main engine of a MicroCloud, and in a way, MicroCloud is just an extension of LXD, providing an opinionated way to deploy it together with storage and networking. So when we move on to the demos, you will see a lot of interactions between LXD and the LXD UI and what we're doing in the MicroCloud itself. The final piece of the puzzle is networking, and here again we are using a trusted open source software-defined networking solution. It is called Oven. It provides virtual network abstractions such as layer 2 and layer 3 overlays. It provides security groups, DHCP, and a lot of other important networking services. So I will now hand it over. I won't be handing it over to Tom yet. Apologies for that. And I will talk briefly about why we are using these components. Well, as Thibaut has mentioned in the beginning, we are an open source company. So everything we do is open source. We have chosen these components because they are production grade. They have frequent, reliable, long-term support releases, which is, of course, very important when you want to use it in production. But more importantly, they have a large community of engaged users behind them, allowing us to collectively innovate and push these components further and further. So in a nutshell, MicroClouds are meant to be automated so that they can be deployed in minutes, even by people that don't have necessarily deep infrastructure skills. It is meant to be simple so that it can also be operated in an easy way, and it can be kind of a gateway towards anyone that is learning how to use clouds. And of course, it needs to be reliable because it is the foundation of everything that you need to do in order to run your systems and applications. So let's take a look into each of these individually with some practical examples as well. So the reason why MicroCloud is different is because the deploying infrastructure components that is typically very complex, we are kind of removing that burden in MicroClouds. Usually, you would have to, deploy each of the components separately. You would have to cluster it across all of your systems. You would have to configure it individually and then connect it. And there is various different problems that can occur during this process. It might be complex to interact with. There may be dependencies or versioning issues if you're running one component in an older version and another one in a newer version. And if something goes wrong, obviously, you may have a problem. In MicroClouds, we are using a snap-based approach in order to mitigate some of these risks. And previously, in Canonical, we have been using snaps for packaging different applications, especially in an embedded world. However, now we're extending that approach towards infrastructure as well. And this is useful because when you package something in a snap, it is packaged there together with all of its dependencies. So it is more efficient, it is self-contained, so everything that the application needs, it's already there in a container. It is confined, which means that it's basically running in its own sandbox. So if something goes wrong, it won't affect the other pieces unless it's specifically allowed to. It also has bandwidth-saving updates, which means that when you're upgrading from one version to the other, only the delta gets sent over the network, which means that upgrades are very fast and very easy. So even if you have limited resources, it kind of happens very quickly, and you can do so remotely. But importantly, they're also self-healing, which means that if something goes wrong during an upgrade, it automatically rolls back to the previous version so that your workloads can continue to run uninterrupted. So MicroCloud essentially takes each of the components that I spoke about a bit earlier, storage, networking, and compute, and then puts a wrapper around them, orchestrating them, connecting them, which at the end results in a fully functional cloud. So now I will actually be handing over to my colleague Tom, who will actually explain the technical details and also show what does a deployment look like.
Great. Thanks, Miona. So I just wanted to talk a little bit about what we see in front of us here. So this is running MicroCloud right now. It's 3 Odroid Intel N6005 machine motherboards, and there's a diagram here showing the overall structure of it. Each board has got local NVMe storage underneath the motherboard, which we will be using for for ZFS, and then it's got an external SATA SSD that we'll be using for the Ceph storage. The 3 orange cables you can see are connecting to what we're sort of showing as an uplink router, so it's a shared L2 network, and that's your site router, effectively. And then we are bridging that into each node.
So let's see it in action.
Okay, so this is running on my laptop. I'm connected to the router via Wi-Fi, and this is the LexD UI, and I'm connected to, as you can see, one of the IP addresses of one of the nodes there. We've got projects on the side here now. I'll go into projects a little bit more in later steps, but in a nutshell, projects are a way of grouping your instances. And when we say instances, we mean virtual machines or system containers. So we've got a project that I've got here called Demo Setup, and we're actually going to be, we've got a running MicroCloud now, but we're going to be setting up a brand new MicroCloud inside these VMs. And I've configured storage to be passed through into those VMs to represent the same setup we have here. I'm going to set up MicroCloud on the 3, Demo 1, Demo 2, and Demo 3, and then we'll add Demo 4 as an additional member later to show how we can grow the cluster. So for this, I'm just going to switch to my terminal. And I'm going to be switching back and forth between the terminal and the UI, just to show that you can use both. But I'm literally SSH'd into that top motherboard there, the same as I was connected on the UI. So I've got Demo 1, Demo 2, and Demo 3 running. I'm just going to switch in to Demo 1 now. And I'm going to run a single command from one machine in that cluster to set up the cluster from fresh. So I'm going to run, if I can type, MicroCloud init. That's a good start.
This is what happens with live demos.
This is live demos, isn't it? Let me reset it. This is why we do it in virtual machines.
Now you're looking at live troubleshooting and resetting the environment.
Yes, I'm deleting the disks, re-adding the disks, and then starting the machines again.
let's try again.
Just wait for that to come up. Okay, right, MicroCloud init. There we go. This is typical. We've done this repeatedly.
We were testing it before and it worked smoothly,
Yes.
but you know, it's the curse of the live demos.
Yes, indeed.
We didn't want to pre-record this to make it real, and now it's real.
Let's see what's going on here. I wonder. Oh no, it's not working, is it? No.
Let's try again. And in case it doesn't work, I suppose we will continue with the rest of
move on to the
the
next one.
demos and come back to this a bit later.
No. Let's move on to the next one, I think.
Yes. Well, this kind of makes it a bit complicated because some of the things we wanted to talk about were hinging on us being able to show that you can deploy your MicroCloud in a couple of minutes. But while I'm talking a little bit, Tom will double check what went wrong, and then we can maybe try it again. Okay. Should we move on to the next demo then
Yes,
instead?
let's do that one.
Okay. We'll go back to the automation and the automated deployment. Apologies for this. I suppose it happens with live demos. Hopefully, we can fix it and still show you what is going on. But in the meantime, let's pretend that we have deployed our MicroCloud, because we do have one running on these boards.
Yep.
And again, deploying your cloud is typically something that companies only do once. So it's not something you will be doing every day. But then once your cloud is ready, it's equally important to be able to operate it in an easy way. So let's take a look at some of the common operations that you can do with MicroCloud, and then we will also look into a real-life use case after this. So handing over back to Tom.
So I'll just talk you through some of the different concepts that we've got. So I was talking about projects earlier, and I'm going to create a new project. I call this demo testing. And I want to add resource limits. So as I was saying, projects allow you to group different instances that you may be running for different departments, different teams, or different types of application. And you can apply resource limits. So if I scroll down here, I'm going to create a project, and I'm going to say that the maximum number of virtualized CPUs that this project can use is 4. And I'm going to do this. I'm going to create, and then I'm going to create this project. Okay. And now I'm going to create an instance inside this project. For this, I'll call this desktop. And you can see that we use a mixture of predefined images or custom images. So I'm going to use a predefined desktop image. I'm going to select desktop.
And here you can use the provided images from our remote servers, but you can also have your own with your own custom images.
And I can choose which motherboard or which node in the cluster I want to provision it to, or I can choose any, and LexD will pick one. So I'm going to choose pin it to Micro 1. For the next bit, I'm going to, remember I said that we had Ceph and ZFS storage. I want to run this VM on ZFS, so I'm going to override the storage pool that we use for local. and I want to connect it to the oven network, which is spanning all three. So when we set up MicroCloud, we created an oven network which span all three of the clusters to create a virtual L2 across them, which is private for all of the instances within that project. We call that ETH0. Okay, create and start. Oh. Let's go, sorry. Do that again. Do local. If not, and I'm going to specify 4 CPUs that I want for this VM. There we go. So that's creating that now. So that's downloading the image from the network over the internet. That will be a desktop-based virtual machine, so it'll be a full Ubuntu desktop. And when that's downloaded, we will be able to start it and go into the console via the interface and also see the visual console.
And of course, the process of the image download depends on the size of the image. In the case, we chose to show a desktop image just because it is interesting to see, but obviously it's a larger image. And it's taking a little bit of time over the venue Wi-Fi. But again, that's the part of doing business. Maybe while this is setting up, you can show some of the profile settings that we could do instead.
Yes, so we can see profiles. Profiles are, so instances are made up of configuration, so how much memory, how much CPU, and they also contain device types, so different types of network, disk, so you can attach disks from different storage pools, different networks. We'll touch on it a bit more later, but we can attach things like GPUs or serial devices. If we go to networks, we can see the networks we've got here. The default, we can see the type, which is to the uplink is the physical uplink to the router, and the default is the other network that we're using at the moment. So let's have a look and see if that's launched down. Oh, sorry, I'm middle clicking. Go back to demo testing. Okay, that's launched. Let's start that up now. Okay, so if I click into that desktop now, you'll see the memory that's been allocated to it, and we should just get, once it comes up in a minute, I'll be able to go to the terminal. Okay, so we can see that's running now. And now if I go to the console, it's just starting up now. Here we go. So that's a full Ubuntu desktop running here. Okay. So let's try going back, creating, and if I stop this now, and this will be a clean shutdown. There's different modes. You can do a forced shutdown just to terminate it, or you can request that the virtual machine shuts down cleanly. And if I go and create another instance, call it VM2. I'm just going to test now the CPU limits. So resource limits, and I'm going to try and go over our resource limits if I applied that correctly. There you go. So this is showing that we are not allowed to create that virtual machine because we've gone beyond the CPU limits that we've set for that project. Okay.
So instead of us spending time showing you some basic operations, which you can explore at your own convenience, let's talk about some real-life use cases. And currently, we do have a couple of customers that are running MicroCloud in production. We have a government institution that is using it to run their analytics in an air-gapped system. We have a research institution that is using it for their research processes. And we have a systems integrator that is using it to deploy it as a customer solution. But let's for a second just imagine that you're a consumer goods company, you're launching a new product, you will be opening it up for pre-ordering at a specific time, at which point you will expect thousands of people to go to your website and click shop now. This means that you need to manage incoming traffic so that your website doesn't crash. So how would that look like if the website were to be run and hosted on MicroCloud? So let's take a look at another demo.
Okay. Okay, so.
Switch the screen.
Yes. So we've got a demo Terraform project. And at the moment, I've got a single container running in there that's got Terraform running inside it. So I'm just going to switch into that. Okay. And so what we're going to show here is how to use Terraform to describe the infrastructure that you want to set up, because LexD has a Terraform provider. And it will then apply those changes and make your infrastructure configured how you have described it. So it will apply using the API directly to LexD and make those changes. So let's just talk. I won't go too much into how Terraform works, but I just want to give you some brief descriptions. So we've got different files here. So they're describing the instances that you want created, the networks that you want set up, profiles, etc. So if I have a look quickly at this one, which is the instances, I don't need to explain all of this, but the key thing here is that I'm specifying count equals 3 because I want to create 3 instances automatically. So if I'm having, I want to set up a load balancer in Oven and then distribute incoming web traffic to different backends. So if I try apply now. So this is running Terraform, and it's identified that it needs to create instances and a network and an oven load balancer. So that's going through now. And what we'll do once this is done, so the application that it's deploying is a very basic Python web server that's just going to respond with the host name of the web server that's being spun up. And then I'm going to run a test which is just going to effectively curl the load balancer address repeatedly, and we'll see that distribution happening. The load balancer itself is baked into Oven, so it's actually a load balancer at the network layer. Okay, so if I have a look at this Pong script, I don't know if you can all see that, but basically what it's doing is it's in a loop, it's just using curl, and then it's hitting the endpoint of the Oven load balancer. So if I run that now, we can see that it's different backends are responding, backend 1, backend 2. It's not exactly round robin, it's basically a random distribution, so it will even out over time. Okay.
So the reason why we wanted to show this specifically is because, again, MicroCloud, you can obviously operate it through the UI, through the CLI, the way you want to, but then it's all API-based. So you can integrate it with your familiar tooling, whether it's Terraform, Ansible, or something else, or you can develop your own provider if that is what is relevant to you. The third part we wanted to talk about is reliability, and obviously we already failed because we weren't able to deploy it, but we'll try that again in a moment. And then the reason why we want to talk about it is because obviously distributed clouds do have some additional requirements. If you have, a main data center, you will likely have, a whole infrastructure team that is going to be maintaining this and taking care of this. But if you have 10 of them or 20 of them that are scattered across, you need to be able to maintain and operate your clouds with low or with no staff. You also need to, there needs to be a resiliency of service. So if something goes wrong, if one of the machines goes down, everything continues to run uninterrupted or with minimal interruptions. And you need to be able to do remote maintenance and upgrades. Also, what is kind of nifty, if you want to run many microclouds scattered all over, you should be able to do that if you have even limited resources. And I mean, we are running it in this box over here, which is powerful, but probably not what you would be running in your actual data centers. And of course, it needs to be secure. So let's put some of this to the test, and hopefully it goes better than the deployment demo. And again, I will switch it over to Tom to show us some of these functions.
Okay, so what we're going to do, first step is we're going to create a instance, a VM, that's using a pre-created image. So in LexD, an image is a root file system or a disk image that has been pre-configured. So we earlier pre-configured an instance containing containing Nextcloud, just really as an example of a web app that you can browse to and have a look at. So I'm going to go into the console. I'm going to have a look at my projects, and I can see I've got a project for Nextcloud. So I'm going to switch into that, demo Nextcloud. And at the moment, we haven't got any instances in there at all. So I'm going to launch one using, which is rather hard to type here. I'm going to use my history to go back.
Yeah, a little bit of sympathy for Tom because his computer is slanted and the keyboard is not really at a proper angle.
So actually, I've got a script here I can show you. It's pretty easier. Demo Nextcloud launch. So this script will launch a Nextcloud instance from an image called Nextcloud in a project called Demo Nextcloud. And we're specifying here that I want to use a storage pool of remote. So that's the Ceph storage pool that's spread across all those 3 nodes. I'm going to use a static IP address. And by specifying that, it will create a DHCP static lease. So that instance will still use DHCP inside it to get its IP address, but it will always be the same address. And I'm going to specifically target it to Micro 03, and that's important because that's the bottom motherboard. So let's run that. Okay. If I go back into the interface now, I can see that that's appeared and is running. I'm just going to give that a few seconds to come up. Because it takes a few seconds to come up normally. There we go. I should be able to go into the terminal and have a look. Okay, so it's running. There we go. So that's Nextcloud running inside that container. So what I'm going to do now is I'm going to unplug the power on that board to simulate a failure. I'll just show you where we are at the moment. So if I do Lexi cluster list, I can see the 3 nodes, and it says the third one, Micro 3, is fully operational. So I'll go and unplug that now, like that. Now, LexD uses the Raft protocol for its database replication, and so it takes a couple of seconds for it to detect that it's down. So we'll just wait for it to pick that up. And what I can show you in the meantime is that this is definitely down now. So I'm refreshing it, and that's gone. So let's have a look. Okay, so Micro 3 is now considered to be offline. If I do Lexi list again, I can see that that Nextcloud instance is now in a state of error. What I want to do, because I ran that instance on the Ceph pool, all the blocks of that drive are being replicated onto the other 2 servers. So what I can do now is recover that onto one of the other boards. So I'm going to recover that onto Micro 02 using this. Okay, and then what I'm going to do is start it up. Now, sometimes there's a bit of a delay here because Ceph under the hood is still waiting to release the locks that prevent multiple instances using that block device at the same time, which we wouldn't want. So let's have a look. Start that up. usually takes about 10 seconds or so. Now, what we do have is the ability to schedule that. So you can say, if your node goes down for a particular period of time, it can automatically move any of the remote-based instances and restart them back up on a different system.
So it basically heals itself.
Yeah. Okay.
There we go.
So that's started up now. So again, remember, it did take a little while to start up. I'll just go and have a look here. Just make sure it's running. You can see it's running again now. So it's up and running. I'm just waiting for MicroCloud to start up again, which took a few seconds last time. I just keep refreshing. There we go, something's happening. Okay, so that's now running, and we've migrated that workload from one machine to the other. And what I do now is I just plug that back in, let it boot up. And then I'll show you that the cluster basically recovers itself and automatically recognises the node is back up. So it's going to take about a minute or so to boot up. Yeah, so you can set the healing threshold to a period of time, and then if it detects that one of the nodes is down, it will then, what we call it, evacuate the instances to a different node. Okay, so it's coming back up in a minute.
Almost there.
There you go.
There we go.
So that's now fully back online, and I can use that machine to run other workloads. The next part of this demo is live migration. So I'm going to go to my migration project, which is here. So this project, what I'm going to do is I've got two instances. I've got a container called C1 and a virtual machine called V1. They are both connected on a oven network, and I'm going to move V1 between physical hosts live whilst it's running. And then to show that that's happening, I'm going to be running a ping on C1 to V1 continuously, so I can see if it's dropping any packets whilst I move the workload. So let me start those up. Now for this, I need to split my screen so I can get the ping up and running. Okay, there's C1. Okay, and I'm going to go into C1 now. Now, one thing that this does show is that the ability to, so what I'm going to do here on the right-hand side is I'm going to ping V1 from C1. So that shows that that DNS records for each of the instances have automatically been created, because I can start pinging that now by referring to the instance name rather than the IP address. And I'm going to do move V1. I can see currently that V1 is running on micro 02 at the bottom here, so I'm going to move it to micro 03. You see it's still responding to pings. Keep an eye on the sequence number, so 25, 26. You drop one, so we drop one there, and now it's back on 29, and that's running again. And then I'll just show you that's been moved to micro 03 now. And what I'll do is I'll move it back as well. So again, keep an eye on the pings. There you go. So dropped a couple there, 49 to 52. And I can see it's back on micro 02. And if I shell into V1 and run uptime, I can see it's been running for 1 minute, so it didn't get rebooted in that process. Okay.
Okay. Now I will talk a little bit more and give Tom time to troubleshoot the first part.
Yep.
When I spoke about the snaps and how they're very nifty and how they can be super useful when we're running infrastructure components, I spoke about seamless upgrades. Now, obviously, we have had our first release of MicroCloud a couple of days ago, so there's nothing new to upgrade it to. But what we can certainly show is what does it look like when one of the other components gets upgraded. In this case, we will be doing this with LexD. I know that this is small, but I will briefly explain what is going on in the screen, so hopefully everyone can follow. But here we are showing a LexD deployment. It's running 4 instances, 2 containers, 2 virtual machines, and currently the version is 4.09. On the right-hand side, you can see the IP addresses, and we're SSHing into each of these instances, and we will be showing the processes running inside as we are proceeding with the upgrade so that we can show that it's running uninterrupted. So what we're doing now is just refreshing the snap to the latest version. 4.0.9 is a version from 2020. And we will just tell it to refresh. It will download some of the things, and then it will start LexD back up again. Right about now. Okay, it's refreshing. And that's pretty much it. If we run the list, we see all of the instances are running, but then if we check the version, we see that this is version 5.17, which was released about a month or 2 ago. So this whole thing took less than a minute. The component was upgraded. All of the instances continued to run uninterrupted, and you didn't need to reboot your systems. So imagine now that you have many MicroClouds all over, a new LTS version comes up. You can just kind of manage it as a fleet, push the upgrade at the same time. It happens very quickly. And then in case something does go wrong, it actually reverts back to the original state, which is pretty nifty. Now, we have shown some things. We didn't show some things yet. But obviously, we only have so much time, and we don't want to bore you with a bunch of, features and CLIs and all of that. But LexD has quite a lot of functionalities. MicroCloud, as a wrapper around it, kind of adopts all of that. So I just wanted to mention a few that might be important for some of your use cases. As Tom has shown in some of the earlier parts of the demo, you can easily run predefined and custom images. And this is, in a way, your templates. So you can predefine the things that you want to do, save the images, and just launch instances as you see fit. It supports NVIDIA GPUs and vGPUs, as well as hardware network acceleration through SRIOV. So for those use cases where you need to have acceleration or more deeper and better processing power, you can easily do that. Because MicroCloud is built on snaps, it also runs on Ubuntu Core, which is our lightweight Ubuntu version that is meant for embedded devices. And this is the kind of resource-saving part, because if you want to just have like a small thing to process some of your data, you can run it on Ubuntu Core and on a simple hardware. And then it can be combined with real-time kernel for ultra-low latency workloads. In terms of the roadmap, this is pretty much showing what kind of we have been working on over the past year and what are some of the things that we will be working on next year. We are now in the middle with MicroCloud 1.1. We have worked over the past months on some of the quality improvements. We have added pre-seed support, so that you can just kind of define a YAML file and have everything deployed very easily. And then we have been adding support for MicroCloud functionalities inside the UI. Next year is a big year for everyone in Canonical because it's an LTS year. We are going to be launching a new next Ubuntu long-term support release, and a variety of other products will be launching their long-term support versions. For MicroCloud, the two main things that we want to get into the LTS is disaster recovery options, because for some use cases, high availability is not enough, and some customers would want to have their cloud completely replicated. So if one goes up in flames, you have all of your things running on another one. And then we also want to enable fine-grained identity and access management. We already have that on the core side, but we need to do a little bit more work in order to expose it towards the users. And then after that is completed, the rest of next year is really all about multi-site management. We already have the concept of remotes, but we have a little bit of homework to do in terms of how this is represented in the dashboard. So Tom is telling me the deployment is working now. So let's go back to the automation bits. Fingers crossed.
Let's pick up where we started. So I've run MicroCloud in it now. What the issue here is that we're running these VMs that I said earlier, and we've effectively installed MicroCloud, MicroCef, MicroOven in the VMs to say waiting to download them. We've then taken a snapshot of that VM, and for each of the time we do the demo, we reset the snapshot and reattach the disks. What happened was it looked like there was a typo in there, and the reset script wasn't resetting the snapshot, so we were just getting the same one over and over again. So MicroCloud in it, I'm running that on one server, and the first thing it asked me is, well, what is the network that I should search for to look for other MicroCloud servers? So I'll do that, and it's found Demo 2 and Demo 3. So I can use just the cursors to press space and select the ones I want, or I can use a shortcut of just pressing right-hand key and it will select all of them. The next question it asked me is, would you like to set up local ZFS storage? So I would. Now so I haven't had to actually log on to every machine. It's gone out and found all of the information, what's available, the different hard disks that are available on each of the VMs. So, and I can type, I can filter. So I want to use the 30 gig disks that I've attached to these VMs for local storage. So I can just type 30 and it filters that down. I can press right again to select all those. And now it's asking me if we should wipe those disks. So I do want to go ahead and do that. Now it's asking if it would like to set up distributed storage. So yes, I do. And you can see now that the 30 gig disks that I picked have been removed from that list, and it's just left with the 50 gigs. So I'll select those and again wipe. Finally, it's asking me, do we want to set up distributed oven networking, which I do. Now, with distributed oven networking, as we said before, the oven networks are effectively overlay networks that are virtualized and create a virtual layer 2 spanned across all of the motherboards. But for external connectivity, we do need a physical port that is connected to the same L2 network on all the different machines, and that allows for the egress to be moved. If one machine goes down, the next machine will be used for egress onto the external port. So this is a spare port that I have on those VMs, and it's going to ask me the IP address of that uplink router, so I'm going to put that in now. And it's going to ask me what is the first address in the range for use with the oven virtual routers. So oven virtual routers, as the name suggests, are virtualized routers, one per oven network, and they will claim an IP address on the uplink for use for SNAT. So by default, when you make egress traffic, the traffic will get source natted to the IP address on that network. So I'll take that. Now, what I've done is I've specified a range on that router that's not going to be used for DHCP, so I know those are free. And we do fully support IPv6, but we don't have connectivity here, so I'm just going to skip that part. So now, sorry, go for it.
Yeah, so now this is all we needed to do. We just run one command and we pre-select some of these things. We were toying with the idea initially to make everything completely automated, to keep specific list of requirements and so on, but obviously you do want to have some control over which disks you're actually using and which networks you're connected to. What is happening now is that MicroCloud first initialized the first server, the one where we run MicroCloud init, and started the creation of a MicroCloud cluster. It then talks to LXD, Ceph, and Oven and initiates their cluster creation for each of these components respectively. It issues some join tokens to these other machines that are on the same network and sends them over the network, which then allows these servers to be included in the cluster. And then at this point, the other servers will start initializing their services and joining the cluster. Finally, when all of this is formed, MicroCloud will actually configure LXD. It will set up the basic networking and storage configuration, and it will also configure the first initial default profile, at which point our cloud will be fully functional. So it is almost there. We see that demo 03 has joined the cluster, so we are only waiting for demo 02, which should take Another
Okay.
20, 30 seconds
Just
or
joined.
so,
There you
and
go.
there we go. It is now configuring cluster-wide devices. And in a couple of seconds, we will have our cloud fully functional and fully ready.
And what I'll do is I'll show you what we've got installed on those systems and what has been configured. Okay,
There we go.
so let's have a look at what is installed. So these are the snaps that were pre-installed in these VMs. So we've got LexD, MicroCef, MicroCloud, and MicroOven. Apart from that, this is a totally blank default Ubuntu VM. And if I do status, cluster list, I can now see that MicroCloud has set up a cluster between those three. And let's look at some of the other components. So we've got MicroOven, micro 2 O's. MicroOven has been set up, and we can see it's got the services that are running on each one of those members are the central service, which is the centralized database for Oven, the chassis, which is the external connectivity we mentioned earlier, and the virtualized switch. Let's have a look at Ceph. So again, similar output. MicroCef status shows the different Ceph services that we've got running on each of the nodes, and we can see the disks. But we can also have a look at the disks directly via this.
Disk.
Okay, so these are the disks that we specified earlier, and they're 50 gig, and you can see that those are being added to the cluster. On the LexD side, if I do LexD cluster list, I can see the cluster in LexD that's been set up with demo 1 being the database leader. And I just show you a little bit of what it's set up. So storage list shows the two storage pools, local ZFS and remote Ceph. And I can do network list. And I can see that it's created this default oven network, which will be used in the default profile. We covered profiles a little bit earlier, but I'll just show you how it's set up. So the default profile is configured so that any instance you create just by default will take on this profile. And so you will get an Ethernet NIC device connected to the default oven network, and you will have a root disk device connected to the Ceph storage pool. And on the earlier demo, we showed how you can override that on a per instance basis.
Yes.
Okay.
And let me go back to the slides. I won't go back all the way in the middle on the parts that we skipped when the demo first went wrong. But as you can see, going from kind of 0 to having your cloud fully functional, it takes about 2.5 minutes when you're having 3 machines. We have tested it in the lab with more. If you're deploying 25 instances in systems, it takes about 7 minutes, which basically means that you can have your cloud up and running very, very quickly. You don't necessarily need fully skilled infrastructure engineers. Obviously, you do need to understand a little bit about what's going on, which networks you need to select, which IP ranges you need to use. But at the same time, you don't need to configure any of these components manually. You don't need to interact with all of the nodes in the cluster, and you can just do this in a much simpler way. Now, next year, before we move on to the questions, next year, as I mentioned already before, is a really, really big year for us. We are celebrating 20 years since the first Ubuntu release and since the existence of Canonical. So I do want to invite everyone here, both in the room and watching online, to follow us so that you can see all of the interesting things we have planned for the 20-year celebration. And now we can move on to the questions. For those in the room, please just raise your hand and Thibaut will be there with a microphone. For those online, just submit your questions, and similarly, he will see them and tell them to us. And again, apologies for the mishap in the demos, but that's what happens when you're doing live demonstrations. But hopefully we were able to just showcase to you how easy it is to deploy, but also how easy it is to use MicroCloud. And then it's really up to you to test it out and really try running whatever you would like to run on top. Any volunteers to break the ice?
We have a bunch of questions online, so while you all think about your next question and raise your hand for any question, I'll get started with a few online questions. The first question online is, how much does MicroCloud cost?
So it doesn't. It's fully open source. So if you want to, you can just go ahead right now, deploy it and install it. All of the components and everything is fully open source. If you do want to have enterprise support, if you're running it in production, then this is priced very simply with Ubuntu Pro. So the cost is per machine per year, and there are really, you can find more detailed information on our website. We do have a question here in the room.
Hi, thank you so much for the presentation. Looks very interesting. We're actually an existing user of one of your products, MAS, so we're using it right now. And my question is, with MAS, you can deploy VMs, containers, you can deploy bare metal. So is MicroCloud MAS on steroids, or is it a completely brand new product that's supposed to replace MAS?
Yeah, so in the MAS case, MAS is a bare metal provisioning tool, for those that don't know, and it is really intended to do bare metal provisioning. Now, it has support for running some virtual machines or containers, which are more meant for kind of troubleshooting and development purposes, but running it long-term and in production, you would need some of the additional capabilities that MicroCloud provides. Now, if MAS, with its current capabilities, suits your use case, then that's great. But MicroCloud is really intended to be a full-blown cloud that you can configure, segment, and utilize for a variety of different workloads. It is also meant to work seamlessly with MAS. We didn't want to kind of couple it together because in some cases, if you want to run just a 3-node cluster, having a MAS controller might be a bit too much. But in case you want to use MAS to provision your servers, you can still use it and then just deploy MicroCloud on top so that you can take advantage of all of the additional functionalities that it has.
Yeah, and I suppose the other thing is that MAS isn't opinionated around storage, so it doesn't provide the help to set up things like microceph, micro-ovens, so you would be needing to do that yourself as well.
I was going to say next online question, and then we'll come back to the room.
Sure.
What are the specific use cases for MicroCloud?
So there are kind of 3 main areas that you can use MicroCloud for. If I start more on the community side, obviously MicroCloud is very nifty because it's very resource efficient, so you can use it, for your development cluster or for your home server. In production, you can use it in the same way as you would want to use a traditional private cloud on a smaller scale. So you can really run it at the back of your office or run it in your factory in order to process some data or do some kind of, video processing. Essentially, for whatever you need compute power, you can use MicroClouds for. When it comes to edge use cases, we do see MicroCloud running on Ubuntu Core as something that can be useful when you want to run it across thousands of sites, because then you can use all of the Ubuntu Core mechanisms to manage it as a fleet and just simplify the way you interact with your edge devices.
Brilliant, thank you.
Hi, do you support replicated clusters and integration with things like Kubernetes or other registries to pull container workloads into?
Yeah, so when it comes to Kubernetes, you would be running it on top of MicroCloud using our MicroClouds. Yep. In case you're familiar, it's basically our opinionated Kubernetes distribution that is conveniently also packaged as a snap. We will be doing some experience improvements on that front so that some of the configuration happens easily and automatically, but you can already just deploy MicroClouds on top and run your Kubernetes-based workloads without any issues. Thibaut, there is one more question.
I was going to go for an online question. What is the minimum hardware requirement that someone would need to give MicroCloud a go at home or in a kind of lab setup?
So So we don't have specific minimum hardware requirements in terms of actual specs, but in terms of, because it's opinionated, you do need a certain amount of hardware. What I mean by that is that we will expect 3 nodes at a minimum. You'll need a shared L2 uplink network, so a physical interface that's unused for an uplink network onto network, and you'll need at least 2 empty disks per physical node if you're going to use both local and remote storage. Although you saw in the setup that you don't have to use both local and remote storage, so you can pick and choose that.
An important thing to mention when using local storage, obviously requirements are much lower. Ceph can get memory hungry, so in case you do want to run Ceph, we recommend at the minimum 4 CPU cores per machine. We have run it with less, but especially for production workloads, we would recommend slightly more powerful machines in case you want to use distributed storaging. But still, in comparison to other comparable solutions, the requirements are quite low, and you can reuse even some of your older hardware in order to run this.
Hello, just a question. Does this run on ARM architectures?
Yes, it does. It runs on both ARM and AMD, so you can run it on whatever you prefer.
Can I run this on my Raspberry Pi?
Yes, you can. We have tested it on some, probably not on the old ones, 1 or 2s, but the newer ones, and certainly the newest that just came out, you definitely can.
Yes, we've tested it on the Orange Pi as well.
Yes, it runs without any issues.
So next question from Wagner on LinkedIn. Could you highlight and clarify the difference between microcloud and traditional cloud computing?
Sure. So, I mean, in terms of the outcomes and what you actually want to run on top of your clouds, there's no difference. So you can run whatever types of workloads that you would like to. The difference is really on the inside, because we have taken these infrastructure primitives that are traditionally kind of complex and difficult, packaged them in a lightweight way, and orchestrated and automated clustering and deployment. So what we have done is removed some of the complexity that you usually have, but in terms of the outcome, the feeling and the usage of it should feel quite familiar.
No more question.
One down here at the front and one
So
here.
there is one more.
Trying to be equal between online and offline.
So I come from a HPC world, and we do something similar to this, but we have 2 areas. One is, like I said, a cluster with minimum 3 nodes and things. The other area is that we don't need a cluster. We just need containers parallelly running, because that's what we do pretty much with, we work with cloud partners. If I have to spin up, like, right now what we do is we spin up 500 containers in Azure, each with 128 cores and 512 gigs of RAM, etc. So if I were to do the same thing, would I be able to do the same thing locally? Because what we don't have is, we are a hybrid company. We have on-prem and Azure. We burst to Azure. So if I were to do, would this help me do the same thing, to use it across local and any cloud partner at the back end?
So at the moment, I mean, if you are using some third-party tools that allow you kind of management across both private and hybrid clouds, you can do you can integrate it via the APIs. We don't provide any tooling at the moment that would allow you to do this across. But again, it's all API based. So if there are any tooling that you would use otherwise, it's not that much work to add MicroCloud as the endpoint and then orchestrate your workloads across both the states. But at the moment, we don't have any functionality that will allow you to do this at the same time.
The API itself is RESTful, so it's literally, you can make HTTP requests to create instances, to stop-start.
There was one more over there.
Everything we do is through our own API. So the LexC command talks to the API. The interface is talking directly to the API.
Before we go back to the offline question, let me ask you one of the online questions.
Sure.
What is the difference between MicroCloud and edge solutions that Canonical offer?
So MicroCloud is kind of something in between. If you look at the entire compute spectrum, you would have public clouds, private clouds, edge, and then MicroCloud somewhere in between, because they take the regular infrastructure familiar services that you can find on the larger scale clouds, but then move it a bit closer towards the edge. So it's kind of in between, but again, MicroClouds are meant to be small clouds. They don't run on single nodes like some of our existing edge solutions do. They are highly available by default. So they are kind of an in-between solution that connects both of these worlds.
So I had a question on the Nextcloud demo, which was moving workloads and thinking about basically the high availability of something going wrong. It was kind of a manual step to move the workload, and you said that that can be configured, as self-healing. My question is, if separate to the configuration of self-healing, if there is like an option for priority. So if workloads are moving because of a fault, and then the fault is rectified, will that priority? Is there an option to have a priority where it will it go back to the resource where it should have been, or will it just stay where it was?
Yes, I see what you're saying. So you want like a group of services that need to be run close together on one host, and then if it gets moved, does it get moved back again? Yeah. So we have a concept of cluster evacuation, and it will, which we leverage as part of the healing process. So when a VM or a container gets moved, it will be effectively automatically evacuated, and it will be stamped with where it was running previously, so that when that node comes back up, you mark it as recovered, and then it will be, and you can do cluster member recover, and it will move those services back to the original location where they were running.
One thing that maybe we didn't talk about much is that MicroCloud also supports the concept of cluster groups. So if you're running many different servers, you can kind of group them. You can have, okay, these two should be used for, I don't know, databases, and these two should be used for testing. So then when you're actually deploying your workloads, you can just target a group, and then it will be deployed on top of that specific group. So you have several different mechanisms that allow you to kind of segment and group your workloads depending on your needs. More online questions?
Of course, many.
Keep them coming.
Namia questions around about Kubernetes and MicroCloud. How do you compare one with the other? Can you put Kubernetes on top of MicroCloud? Can you elaborate on this?
Yep, sure. So the difference between Kubernetes containers and LXD containers is that we call those LXD containers system containers. What that means is it's running a full init system and gives the impression when you shell into it that it is a full server. You can run multiple processes, multiple services, and it behaves very much like a virtual machine, albeit without the overhead of running a full kernel and a full hypervisor, because it is still using the same technology as Kubernetes containers, which is C groups and namespaces in the Linux kernel. But you can absolutely run Kubernetes on top in a VM or multiple VMs. And so MicroCloud is not application specific. You can run any application that you want on top.
Yes.
Next question, I think, is clarification on the Raspberry Pi question.
Okay.
A single Raspberry Pi won't be sufficient. There's a need for 3 Raspberry Pis.
Exactly, you need 3 Raspberry Pis, or you could use a single Raspberry Pi and run 3 virtual machines on top of that single Raspberry Pi, and then deploy your MicroCloud. But it kind of defeats the purpose. So yes, you would need 3.
You can also use mixed architecture clusters as well, so you can
That's
have
true.
some ARM machines, some Intel machines.
Yeah, we have tested that a couple of months ago with a mix of Xilinx and MediaTek boards, and it worked really well.
Looking around, if there are more questions here.
Yeah, thanks. I think you sort of answered this already with talking about differentiating clusters. But for example, having differential storage attached to some clusters but not others, would that also be possible?
So I think you're saying, can you attach different hard drives to some machines than others?
But also like handling storage differently for different types of machines.
So the MicroCloud setup and LXD under the hood will require, when you create a storage pool, you will require the same type of storage across each of the members. Okay. What you can do, though, using LXD directly, is you can attach external disks to a particular instance. So if you have a particular disk on a particular system, you can connect that directly.
Okay, thank you.
Told that this Mike's battery is dying when more people are asking questions online. The next question online is just scrolling through quickly. What are the connectivity options between public cloud and MicroCloud?
I think I mentioned this before. So at the moment, well, it kind of, we don't provide any existing tooling that would allow you to do that. So if you have any third-party tools that you're using already to connect between your private and public cloud estate, you can easily integrate it, but at the moment we're not providing anything out of the box. And the batteries are being changed, so we will just wait a moment for the next question. Yeah, please go ahead and I can repeat it for the audience.
So I had a bit of a clarification with regards to scaling. I saw the Terraform example, but what I was not clear about is what exactly drives the Terraform scripts in case of scaling based on ingress traffic? Is there a way that MicroCloud has the feature to automatically scale up or scale down in response to traffic?
Okay, so I will just repeat the question because our guest wanted for us to clarify about scaling. We have seen the usage of Terraform, but does MicroCloud has its own capabilities to scale up and down based on the traffic?
Not at this current time. With something we have been discussing internally with a project that would allow you to put application logic into your scaling decisions and then spin up additional machines and extra oven load balancer endpoints. So, but not at this current time.
So yeah, we are in early stages of defining something, but it will take a little bit until it's ready.
And I'll go for the next offline question, sorry, here. But online was a question, what happened if a server is broken and needs to be replaced? I think someone who probably didn't see the demo properly. So do you want to explain that again?
If a server is permanently broken, you can do MicroCloud cluster remove, force to remove that, and then you can run MicroCloud add to add a new server in.
Yes. So you can, if it's temporary damage, it can come back online. If it's permanent, you can just remove it from the cluster. But obviously, at some point, someone would physically need to go and remove the machine. That is not something that we have any control over. But in general, it is very easy to remove a server or to add several and then scale up if you need to.
The next, one of the biggest questions I have, so in your demo, you showed the network storage was connected using Ceph.
Yes.
Can we put anything else there instead of Ceph?
So the solution supports Ceph at the moment. That's the only remote storage driver that we have. We've got other remote storage drivers in the works at the moment.
We've exhausted all the online questions. So if there's...
Okay, one more.
Is there any overhead difference between Ceph and MicroCeph in terms of?
No. So MicroCeph just packages the usual Ceph into a snap. Yes. It makes it a bit more lighter and easier to deploy. But in terms of the services and what it does, it's fairly similar, and it has all the regular features that you would expect from Ceph.
Yeah. In general, Micro Oven, MicroCeph, MicroCloud are effectively just small daemons that are orchestrating that setup.
So they don't remove the functionality, just make it lighter in terms of the footprint.
Any additional questions here?
Then I would just thank everyone so much for your attendance and for your patience as well as we went through the troubles. Thank you to everyone online. We will stop here, but for those of us that are in the room, there are drinks and snacks in front, and then we can also continue with the questions and discussions face-to-face. And for those online, just stay tuned for more interesting things that we have in the works, both in terms of MicroCloud itself, but also all of the other things that we are working with at Canonical.
Thank you.
Thank you.